السلام عليكم. يعطيكم العافية. Welcome to first-time attendees to Google Developer Group. Today we have a talk by Mr. Burhan Khalid about Google Cloud Platform in general, focusing on Google Cloud Compute Engine. Please welcome Mr. Burhan Khalid.
Let's start. Thank you. Okay. Who here does not know what Google Cloud Platform is from the beginning at all? Never heard of it? Excellent. Okay. Who here knows it? Don't raise your hand. Okay, 3 or 4 people. Great. So you guys can correct my presentation slides if they're wrong, and you guys can need to pay attention. Okay, so Google Cloud Platform is basically how you would host your own applications on Google's infrastructure. But before I begin that, let me not get ahead of myself. Today's agenda, well, I'll give you a short overview of the platform because there's many things on the Google Cloud Platform. I'll walk through some of the services that they provide. I'll give you a short demo because it's very quick, it's very easy, and I'll show you some resources that you can use if you want to research on this on your own. And finally, we'll open the floor up to question and answers, as is the normal policy of GDG Kuwait. Okay, so basically what Google Cloud Platform allows you to do is take your own applications and services that you've written and run them in Google's data centers. This is a picture of Google's data center. The only thing I like about this data center is the bicycle, which is also in Google colors. You can see it on the bottom. So what Google does is, because they have huge capacity, as you can imagine, they're Google, and they know how to run resources very well. They rent out resources that are running on their data center for you to use. Okay. So as a general rule, cloud computing is a way to have access to huge computing resources for a limited amount of time. So you don't waste your funds having a large computing resource that you only use 10% of the time and paying for it 100% of the time. So there are many companies that are doing this, and there are many different levels of, let's say, virtualization that you can achieve with cloud computing. Okay, cloud computing, it's not a product. Cloud computing is a term that means basically having your processing power in a remote location other than your local machine. I mean, that's the best way I can describe it. So they say it's over the cloud, because when you're drawing network diagrams, you put the internet as a cloud. So that's the rumor is that's where the term came from. So this is Google's cloud platform. They provide compute resources, storage resources, data analysis, and other services. Okay. This basically covers all that a developer would need in terms of application requirements. Okay, we'll just go through one by one. I'll give you a quick overview of what they are. So, if you want to do computing or you want to host your application, there are 2 options that Google provides. One is the App Engine. This is what they first started off with. This is a platform as a service product from Google. What this allows you to do is basically develop your code in standard languages. It supports Python, PHP, Java, and Go. These are the support languages. And what you do is, once you have finished writing your application, you just send it to your App Engine account, and they will run it for you. You don't have to worry about the server, the protocol, the ports, the firewall, the databases. It's all taken care of for you. Okay. There are some drawbacks. For example, in App Engine and also other platform as a service products, you don't have any access to the disk because there is no disk actually. There's no hard drive. So you don't have write access to the file system. So you have to be slightly careful about how you write your code, and a lot of the system calls that access the disk are blocked. I mean, your code will have errors. But beyond that, which is a very, let's say, it's a very edge case that you would ever run into if you're running an application. But beyond that, everything that you can do on a normal computer that you would have to rent out, buy, and manage yourself, the App Engine will take care of it for you. So this is App Engine, platform as a service offering. Compute Engine allows you to bring up a virtual computer, depending on your configuration, that's running in Google's data center. So it's just a machine. It's exactly like you went and you bought a machine outside, and you configured it yourself. Except you can bring it up in a matter of minutes, and you can take it down in a matter of minutes. And it's running on Google's data centers. Okay? So what Google does is they provide you a template disk, which has operating systems that you can use to boot up your computer. So it's literally you're booting up a computer, except it's running on the cloud. You don't have it physically with you. A compute engine right now supports Linux only. It supports Debian-based distros. It supports CentOS, and I believe one more. I forgot what the name is, like SUSE Linux or something like that. You can place the machines in various different data centers. So you can have the machine in Europe, for example, if your customers are coming from Europe. The good thing about compute engine is that because Google are engineers at heart, they have made an excellent API for these services that allows you to scale up and scale down and bring up machines simply by writing lines of code without even having to go to their online control panel. Is that clear? So compute engine for bringing up machines, app engine for running your applications. You can bring up a compute engine machine and run your application here, but then you have to manage it yourself. You have to manage the database, you have to manage the web server part, you have to manage the ports, everything, the memory. Here, everything is taken care of for you. Okay, so this is for computing and hosting. Next, you have storage. So for storage, there are 3 different kinds of storage that are provided at the Google Cloud Platform. Each does a different job, so they're not all mix and match. I'll start off with the easiest, which is the Cloud SQL. This is basically a MySQL server that Google manages for you. That's the easiest way for me to describe it. It's binary compatible with MySQL. So if you're ever writing any code that runs on MySQL, it will run without any modifications on the Cloud Engine. Okay? You have a limit of 16 GB RAM and 500 gigs of a database size. If your application needs more than that, come talk to me because I want to work for your company. Because I've yet to receive an application that needs more than 500 GB disk, a database, and they're actively using it. Okay? This is Cloud SQL. Cloud storage is a way to store binary files on the cloud. This is like S3 from Amazon, if you're familiar with that. So the concept here is you have projects. Projects have buckets, and inside buckets you put objects. So this object can be any file, can be any binary data. It doesn't have to be a text file, image file, flash file, whatever you like. So this is cloud storage and SQL. Data store is the unstructured data storage application. This is for information that doesn't fit here because it's not structured, doesn't fit here because you want to do queries on it, so you dump it in this location. This is a NoSQL service that Google provides. Any questions? Okay, for those of you taking notes, okay, if you're just writing down what I'm saying and you don't know what I'm talking about, stop taking notes and ask questions. Because you should be able to read your notes and like, oh, okay, I understand it. Not like, he said that the blue one with the SQL is like MySQL. So if you have any questions, raise your hand, ask. I'll stop whatever I'm doing. I'll go back and I'll answer. Question? Don't talk too fast. Because you're writing down what I'm saying, then I'll talk faster. Okay? Because you need to listen to what I'm saying and then understand, write down what you understand from my talk. Because if you want what I'm saying, I can give you the recording of it. So I'll talk faster. Next. Big data analysis. This is BigQuery. This is for doing large data sets. I'm talking about billions and billions and billions and billions and billions. Did you write that? Okay. So this is basically a giant engine that you upload huge amounts of data, and all it does, it runs queries on it. That's it. When I say huge amounts of data, I'm talking about things like all of Shakespeare's novels, all of their text is uploaded here, and you want to know, was Shakespeare's novels mostly positive or negative in their tone? It can crunch that for you. We're talking multi gigs of data. The minimum data that you can upload here is 1 gig. 1 gigabyte. Okay? How this works, you have a project. Projects have tables. And tables have, I believe, queries or plans. And then you tell it, run this query. Uploading data here is free. Downloading it is free. And browsing it is free. Okay? But the moment you tell it, I have, for example, I'll give you an example of the data here. Let's say you have temperature data for Kuwait from the 1940s till today, across all regions of Kuwait. And you want to know how was the temperature going up or down across all these years, okay? You upload that data into this system, and if it took, let's say, half an hour to do this on your laptop, in here it would be a matter of seconds. It's that quick. I can do it in real time, which means as the data is coming in, it can update the queries. It is extremely powerful. Actually, just as a sidebar, Google came up with the big data technology. Big Table was a Google research project. Sorry, what? Use normal SQL. They have an abstraction there, and then you just use that. You can browse it online. There's an online browser, or you can write code and yes.
Why do we use the data?
Okay, good question. This engine is designed specifically for doing queries over large data sets. It's specifically for complex analysis. It's like a, you heard of this business intelligence. This is what this is for. Those, where they store the data, I'm sure they store it in one of those storage locations. But if you store the same amount of data in MySQL, which is the cloud SQL, and you want to run that query, it will not be as efficient as it is to run here. And because the MySQL stops at 500 gigs, 500 gigs is a small amount of data, by the way. Sorry. In the real world, 500 gigs is nothing. It's pennies. It's what they, when you do statistics and you say plus and minus 3%, this plus and minus 3% is 500 gigs. They just throw it away. They don't even consider it. So you're talking about huge amounts of data. Yes?
So basically, for a large amount of data.
Yes, but doing what with it? This is, I'm going to SMS the professor right now. I'm going to tell him, ask this question in the class. It's for doing what with large amounts of data? This is the thing you need to notice. It's for queries. It's for analysis. It's for trends. Like, you want to know, since the history of Kuwait, have there been more girls born or more boys born? Okay, how would you know that? You have to have this data set that you plug into here, and you say, okay, do this analysis for me. You want to know in all of the books ever written in the whole world, okay, are girls mentioned more than boys? What's the most common name? How would you do this? You need something like BigQuery that's designed to do things with big queries. Got it? So, moving right along. Next is services. Services are things that Google provides to help you, take advantage of their resources. Cloud endpoints. This is if you have an application and you want to create an API out of it. You upload the data, it generates the REST APIs for it. Translate API. I'm not going to tell you what it is because everyone here, I'm sure, knows what translation is and what an API is. So this is what Translate API does. Prediction API is really good. This is for things like, okay, don't write that fast, because you're not going to understand what you're writing. So understand it first. Prediction API is, when you go to Amazon and you buy something, there's other users, also bought. You may also like, and it shows you the products. When you go buy something from Amazon, at the bottom of the page, it will say, since you bought this, you may also want to buy these 4 or 5 things. So suggestions, predictions. How do you do that? Because Google knows this very well. And where does Google use this prediction API? Ads. Not ads. When you start typing a query and it starts filling in the rest of it for you, it's the same engine. So you get to use the same power and technology in your own applications. Okay. This is Cloud DNS is mainly for hosting your applications. Pub and Sub is a messaging platform to send messages to other systems for querying. Okay. It's time for my demo, but before I begin my demo, are there any questions in the services that I highlighted? If someone doesn't understand, please. This is the overall slide. So what does this do? Because you're the one writing so fast, so you read your notes and tell me what it does. So I'll make sure you wrote it down correctly. App Engine.
I think it's for, they basically do, you bring your own app.
Okay.
They do theirs.
Which is what? Okay, see? So you should pay attention. So App Engine is, you have your application, like you wrote your application, okay? You need to run it somewhere. You don't want to set up a server. You don't want to download antivirus. You don't want to set up a firewall. You don't want to set up a database. What App Engine does is basically you take your code, your source code, and you upload it, and they will run it for you. That's App Engine, okay? It's for applications. It's an engine to run your applications. That's it.
That engine to get it all over type of server.
No.
No. That's all.
That's all taken care of for you. All you do, it's like Heroku. You know how Heroku works? Basically, you upload your code and they run it for you. In the new version, there's a new service coming with App Engine. It's in beta right now. It's called Manage VMs, where you can actually control the machine that's running your app. So they're bringing it up now. So that's App Engine. Compute Engine. Okay, I'll not pick on you. I'll pick on your friend. So what's Compute Engine? What's this? Okay, your friend. What's Compute Engine? This is the easy one. Yeah, it's to bring up machines. So what you do is you go to this nice form, and you say, I want 2 gig RAM and 1 gig hard drive. Okay, there it is. That's it. It will bring it up. I'll show you now in the demo. What's cloud storage? No one's paying attention. Okay, who can answer? What's cloud storage? Yes. Binary files. Cloud data store? Yes. It's basically, well, what's Cassandra? It's not a name of a song.
No SQL.
No SQL database. And Cloud SQL, this is? No, binary is here. This is no SQL. See, I switched the orders. In my slides, I talked about this first.
It's just like Amazon Cloud.
Amazon CloudFront is here. It's in the cloud endpoint. It's in the services part. That's AWS. Yes. It is it's kind of like for example, AWS is this part. Okay. Beanstalk is this part. EC2 is this part. Beanstalk is this part. This is S3. This they don't have, as far as I know. What? This part?
Yes, no SQL data. I didn't mean to say.
Yeah. This is available now. I believe this is new. They're using Postgres. Google uses MySQL. They don't have anything here, and they have a few of these.
And what about the basic load down, auto load down?
Oh yeah, don't worry about it. Yeah. Even with Amazon, you don't worry about it.
They call it
Yeah. Okay. So yes.
What's the main difference between using an endpoint and writing my own backend?
I believe endpoints are optimized for mobile and for web. So why would you want to do it yourself?
I use endpoints.
Use endpoints if your data is available. If you just have a bunch of data and you need CRUD operations, create, read, update, delete. Question? Sorry? If what? The data is generated by users? Ask me in the demo, I'll show you where it is. Questions? Before I start the demo? Okay. Today I'm going to talk about this part because this is new. App Engine is very old. Well, it's the first one they came out with. I'm going to talk about Compute Engine today. So, put over a chair. What I'll do is, I will, before I begin. In order to use any of these services, you have to have a payment method. They will not charge you, but you have to have a payment method configured, which means you have to have a Google Wallet account. if you're able to buy something from the Play Store, you have a Google Wallet account. So don't worry about it. Okay. So how this works is you go to developers.google.com, which is the main portal for all things having to do with cookies and cakes. Of course not. It has to do with developers. Nothing is being done here. So, okay. And oops, sorry. And you will get something like this. Okay. This is Google's developers portal. They recently reorganized this. It looks more like a search engine now. But basically, they have products for. You can go directly to the product section, which has information on everything that Google offers for developers. So even if you're an Android developer, you'll go here. For Chrome web apps, for Google App Engine. They have specific sections for startups, for mobile developers, for game developers, teaching you web fundamentals, how to create web applications that work really nice on different devices, how to make money from your apps. But what we're going to do is we're going to talk about their products, so which is all the way down here. Okay. As you can see, Google has, I can spend 1 week describing all these for you, but we're going to go directly to the cloud. Okay, this is our discussion today. So while this is loading, here we go. So this is the Google Cloud Platform. This is what I was talking about today. And if you scroll down here, you will see these are the things that I discussed. So there is App Engine, Compute Engine, there is Cloud SQL, Cloud Storage, Cloud Data Store. There is BigQuery. I didn't talk about the Deployment Manager, because it's a bit technical for this discussion. When it's in gray, it means it's not yet ready for production, so I didn't talk about Apache Hadoop. There's Cloud Endpoints, there's the Translate API, Prediction API, Cloud DNS, and Cloud Sub, which is the messaging platform. And of course, you have the developer tools. So how do you use these technologies? You can use Eclipse. You can download the plugin for that. You can download Android Studio if you're going to write Android apps. You can have the Cloud SDK if you're working with cloud. So what we're going to do today is we're going to go ahead and create a new machine online, log into it, and run an application on it. Is that clear? Okay. So if I want to create a new machine, where should I go? Which of the blue boxes? Compute Engine. Great. A for you. Okay. Now, what Google has done is they have pre-configured templates for Compute Engine, so that if you're developing a PHP application, you just click one button, it will configure that machine with everything you need for PHP. Okay? If you're developing Java, Ruby applications, you click on it, it'll set it up for Ruby. But what we're going to do is, we're going to do the Hello World starter configuration. Okay? So as you can see, I'm already logged in to the developer console because you'll see my name here. Okay? And my old icon. Okay. What this is doing now, it's bringing up the form where I'll start configuring the machine. So I'll say that this is what? Oh, is it App Engine now? Oh, oops, sorry. I did the wrong thing. Let me go back and just go to directly to this is where is it? Thank you, someone's paying attention. Okay, so here we go. Let's get started with Compute Engine. So we'll just go try it now. Actually, I already have it loaded, but I want to show you how it works. So this is my Cloud Engine database dashboard. When I clicked on try it now, I have to give it a project name. So I'll just call it my project one. Okay. This is a unique name that Google gives to your project so that it's easy to identify because you don't know how many millions and people are using the same thing. So there might be, everyone who clicks this gets my project one. So imagine how many my project one there is. So that's why they have this unique name. Click on create, and it will start setting it up for you. On the bottom, you'll see the progress. Okay, and because it's doing it live on their data centers, it takes a few seconds for it to get going. Once it's up and running, you'll see I'll get a page to configure my project. I've already done this one. But I'm going to do one from scratch for you guys. There we go. It's done. It's going to refresh my page to allow me to configure my machine. Okay, now, what I can do is, once I have a project, I can create an instance. An instance is the machine itself. Okay? So here you see I was talking about the stack. So this is a lamp stack, RabbitMQ, lamp stack. I don't even know what this is. Mean, oh, I know what mean is. This is for JavaScript. Ruby on Rails, which I hate. Apache Hadoop, MongoDB, Cassandra, GitLab. So they have all these templates. What we're going to do is we're going to do something very simple. We're going to say, I want a blank machine. Create an instance. Okay. And now it's going to ask me to enable billing. Remember I said you have to have enable billing? I'll just go ahead and enable billing. And it should just automatically configure it. I'm in Kuwait. Confirm. Of course, Kuwait is supported. So it's going to ask me for all this information and my card number. So let me just go ahead and do this so that we can. Fine, 65. Please don't send me messages. Okay, now it needs a credit or debit card. I'm going to put my credit card here. Okay, you are free to use it and get a nice call from the funny people over at in the black cars with the blue and red lights. Okay.
Limp is basically just think.
Yeah, I'm gonna hide it. I'm gonna take it over here and fill in my card information. Then I'm gonna bring it back.
You can just do this.
Limp is basically plan with engine access.
Okay. When does this expire? And my code is. Hello. No, it's only shared. Okay. All right, so billing is enabled. No one got to use my credit card. It's okay. If you need something, let me know. Okay. Now that we're back, it's going to take a few seconds and give me a form. There we go. Where I can configure my machine. Great. So billing was set up. Now I'm going to create an instance. This is the name of my instance. I can call it whatever I like. Okay. See how easy it is? I want HTTP traffic or I don't want HTTP. So I say, okay, I want HTTP traffic. So it configures the firewall for me. Where do I want the machine to be located? So I can have it in Europe, in Asia, or in the US. I'm going to put it in Europe. Okay. This is the interesting part. What kind of machine do I want? So you see here, I can go from one CPU with half a gig of memory all the way to 8 CPUs with 30 gig of memory. Up to me.
16 CPU with 60. Yeah.
Yeah.
You get pricing.
Or actually with 104. Which one should I go for? Let's go for this one. See what happens.
It's expensive.
Really? It's gonna kill me, huh? Okay. I'll go for this one.
I think that's in the back.
So
$6 or $7.
$6 and $7 a minute. So once I have my machine type, I need to tell it where to boot. Like, how do I boot this machine? Because I need to have some operating system running on it. So I'll say, create me a new disk image. Basically, create me a new image on a disk and use this image disk to boot the machine. And what's the image I want? So these are the operating systems. Let me scroll this down. These are the operating systems available. Okay. I'm going to just tell it I need Debian, because this is what I like to use. Okay. You can have a persistent disk. You can even configure it with an SSD if you want. Because, as I said, this is a machine. So you can configure it the way you want it. I'm going to leave it as a standard disk. I'm going to give it the default network. You can also tell it to give you a static IP address for this specific machine. I'm going to leave it to ephemeral and create. Okay. So it's creating the instance. And as soon as it's done creating the instance, I'll be able to log into it directly from the browser. So I'll show you how cool that is. If you compare this to how Amazon works, in Amazon, this process is a little bit easier, to be honest with you, because they have because Amazon, what's it called? EC2 has been around for a very, very long time. There are a lot of templates that you can directly clone to create machines. Here, it's more of your, do your own thing. My machine is running, actually. It's up right now, but no one is using it, so there's no CPU percentage to be used, to be shown here. Let me just minimize this. Here is my IP of my machine, okay? This is the instance name. This is where it's located. And this is how to connect to it. So what I'm going to do is I'm going to click on this. What? And you don't have port 22 open. Yeah, which is a secure shell port. So what it's doing now, it's connecting to my server. This is my machine now. So any command that I can type on a normal, just to prove it to you, okay, what I'm going to do is I'm going to run a command here just to see if this machine is up to date or not. Okay, so it's now what it's doing, it's going to the internet using Google's internet, which is why it's amazingly fast, to fetch updates for my machine. When I come down here, you'll see that if I go to 1 hour and I go to network traffic, oops, let it go. Well, it has to have 1 hour passed, otherwise it doesn't show it. See disk traffic. There we go. Toot, 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 toot. That's me working on my machine right now. Okay. Now, let me go back to my. Where is it? It's still working because it only has half a gig of RAM. So imagine if I went here and I did the 106 gig RAM machine. It'll be so fast, I think this thing will burn out. Or it'll show it. So it's done updating my package, and now I can just do an upgrade. Get upgrade. And there are some things to be upgraded. Yes, let me have it upgrade. So now it's going to start upgrading my computer, and hopefully you should see some CPU being utilized. There we go. Some network traffic. There we go. And of course, lots of disk traffic, which is going up. This is the reads and the writes. Yeah. And you can see how fast it is. 1.5 megabytes per second. Okay. So when I'm done with my server, I'm like, okay, I don't need it anymore. It's finished doing what I wanted to do. I can now, as long as this machine is running, I can upload any file to it. I can run any application on it that's available in the world. Like I can, for example, I can install a server and then browse it. But all this that I'm doing now, I don't have to do if I'm using the, which one? The app engine. Because if I'm using the app engine, all this is configured for me. So I don't have to do anything. Where is it? Yes. So now it's configured web server and should be up actually. I'm gonna run it now. Oops. Oh, sudo. Yes. Just to show you guys that it's an actual machine. I typoed it. What?
You're going to set up some basic.
It's a basic server. So now the server is running, and I can now browse this IP. It'll open it up. Yeah, I believe so. And I should have. If I can change this. So now my web server is up and running on Google Cloud Engine. I'm sure you guys are like, what was that black screen? And what the hell was that he was typing? Oh, I didn't understand anything. I don't know why my professor makes me come here. Okay, it's all right. Now, when I'm done with, everyone understand what's going on here? All right. No, no, no. Also no? Okay. What I did, I went to Google and I told them, create me a computer with 1 CPU, half a gig of RAM, boot it up for me with Linux. That's what I did commands. And then I said, okay, let me log into the machine and do something, because why I want to do something. So I want to create a web server in the machine. So this is how I logged into the machine. This screen you see here, I know it's scary because it's black, but it's the actual computer that Google created for me in just like 5 minutes that we were here. And on this server, I can do anything I want. So if I want to experiment, like if I have an application or a database, and I want to just see how it will run without ruining my laptop, I can go here in 5 minutes, get a machine, install my application on it, run it. When I don't like it, I can delete the machine, and it doesn't affect my computer at all. And I will only be charged if I used enough of it so that it's chargeable. You got it? The other way to do it, if this wasn't around, you have to go rent a computer, pay for a whole month, because they only charge you for a month, use it for maybe 5 minutes, and then sit, and it's waiting for you, and you're paid for it, and you're not using it. So this is like electricity. You pay for just as much as you use, right? And you don't go, when you want electricity, you don't go and start building a generator. Why is that? So it's a valid point. You don't go build a power plant, right? It's a commodity. It's a utility, like water. If you need water in your house, you don't go and dig a well. Well, you might. I don't know. It's Kuwait. Sometimes the truck doesn't come and you have to go and get it. But power is a good example. So power, you don't go build a power plant. You just go and you pay the ministry for as much power as you use. If you don't use that much electricity, your bill is very low. And if you use too much, your bill is high. But it's not like you're paying for the whole power plant and you're not using anything. This is just like that. You pay for only what you use. So if I need a very, very strong computer to run a heavy program for 5 minutes only, okay, I can go here and I can bring it up for exactly 5 minutes, and that's all I will pay for that 5 minutes. But if I bought it, I'd have to buy the whole computer, and now it's with me. So let me just shut down my machine. And once, you know what? Let me just shut it down from here. Okay. So this machine is now running. If I go to my project, and here, you'll see this is the machine. It has service 33 requests, and there's no charges till now, because it did not reach that much of use, the minimum amount of use. So what I can do is, I can go here, and Google is kind of smart. If you tell it to delete something, say, okay, we'll keep it for another week. In case you change your mind, you did something stupid, you can come back and delete it again. That's why it says pending deletion. I have some things pending deletion. Okay, this is the entire request. What I can do here is I can go ahead and delete the machine. Actually, let me see, permanently delete this project. I have to shut it down first. So that's why this thing is a billing account is active. So I have to first disable the billing, then I can delete the project, then I can go ahead. But since I have it running, let me show you the other things. Let me show you big data, which is kind of exciting because they have huge amounts of data sets available. So everything clear so far? Where am I going now? To which section? Big data, which was the one, it's easy to know because it's the only one by itself. It's the only blue that was all alone. Everyone else had like 3-5 brothers next to it. This guy was all alone. I have to re-enter my password. Okay. Shall I go through this? Is anyone interested in seeing some big data queries? Okay. This should be fun.
They used it to predict winning in World Cup.
Yes. Actually, the turtle was more accurate, to be honest. Well, that's why they killed it. It was an octopus. Well, no, not turtle. It was an octopus. They used to drop the balls of the two countries, and it would go and whichever ball it would grab, this is the country that would win. So,
11 out of 20.
Which is amazing. Predictions. Yeah.
They only missed one match.
Yeah. Okay. So.
They predicted Brazil versus the final match is going to be Brazil versus Argentina. Brazil is going to win by 5%.
This is the data of all of Shakespeare's works. All of Shakespeare's works. Everything. Okay? So this is the table. It has these. This is a preview of the roads. It's basically telling you how many times each word appears in the corpus, which is a corpus is a collection of text. So you can see that brave 6 times. This is for King Henry. That's the corpus, King Henry. If you know Shakespeare, it's his work. You can go and you can check other things. You can see Wikipedia is available. And Wikipedia, you can say how many contributors were there in big data based by unit times. Now, let me do a fun one, which will be let me see in Shakespeare's timeline. Let me run this query. What happened?
We're not selecting anything.
Good question. So query is complete, and there was an error. Because, see this? I'm opening the validator, and it was expecting end of file here, so select, it's highlighting it. I can select star, but I was just going to show how the error works. So that's that was. So you can just go like that. Now, let's see what happens. Run this query. This query process will take 6.3 megabytes when run. Okay. So fine, run it. So in Antony and Cleopatra, brave 12 times, attended 1 time, holding 1 time, and 1 of 6 rows of 1,000. So I can keep going next.
Yeah, because you're limited to.
Yeah, I'm limited to 1,000. But if I get rid of this, this is going to be a good one. Okay.
Then download as CSV.
Yeah. Okay.
164,000.
So imagine how long this took. 7 seconds to run. If I give you this data set and give you a challenge, configure your database so it runs in 7 seconds. And come and let me know how much it costs. Okay. This is so you can go here And you can find out, select like something interesting. Select any words used more than 10 times? These. I should say one of 6 of 13,355 rows. So these are the words. See how much I is used? 521 times. And I'm afraid to click this button because my computer is gonna. Let me see what happens. Download it. Okay. That's all. Maybe it's downloading only this part. That's why it happens so quickly. Okay. This is BigQuery. Anything else people want? App Engine, I think everyone knows. App Engine is the first one that came up. Sorry? Snapchat using App Engine. Yes. That's not why they got hacked, by the way. All right. My presentation is finished. So if you guys have any questions, more than welcome to answer. But yes.
So if you have the choice between the classic.
Yes, tell me.
Cloud platform, which one would you choose?
It's closed. Close it. The question is, can you tell me the question?
If you have the choice between AWS and GCP, Google Cloud Platform.
Which one would I use? Actually, it wouldn't matter to me right now because I can configure both to my liking. But if I was new, I would recommend the Amazon one because the AMI images are available, so you don't have to do a lot of configuring for you. Right now, the stacks here are very minimal. They have lean, mean, lamp, damp, amp, whatever it is. And if you happen to have the bad luck that you have to run Windows, okay, Amazon AWS is your only option because Google Compute Engine does not support Windows. It only supports Linux machines. There's a discussion going on in the back over there that I would love to be a part of. So I wonder what's going on over there. Hopefully it's something to do with technical things, right? Some discussion going on. Something about this or something personal?
Yeah,
What is it? Share with us.
the app engine company, two of them are separate. So if I want to
The two of them are what? Temporary? No. Yeah.
like for 5 minutes.
If you want it for 5 minutes, you can have it for 5 minutes. Or you can have it running forever. It's up to you.
I think App Engine's free tier is 20 hours per day. So it's, you can have 2 instances, two applications running.
No. What they're asking is, what if I want it permanently? This is your question, right? What if I want to have it permanent? Yes, you can keep it permanent on. The point I was trying to make is, if you need a fast computer for only 5 minutes, this is a lot cheaper than going and buying it. Because essentially you're renting it for 5 minutes, right? But if you want to have a fast computer for, like, I want it for 1 year for my project, you can launch it here. And you don't have to worry about the power, the network, the bandwidth, the security, because it's all taken care of for you. Same with App Engine. With App Engine, a lot of students use App Engine just to test their projects because they don't want to mess up their laptop and install all the drivers and the databases and everything. They just want to have something shown for a demo for a project. They use App Engine. It's up, okay? And if no one uses it, you don't pay anything for it. You can have it up there for years and years and years. You can even duplicate it. Yes.
You can take out instance and store it later use.
Yes. So, any other questions? Yeah. You want me to show you the Google Cloud endpoints? Okay. The recording is off, right? So I can. Yeah. Yeah. Sorry? It's per hour. Yes, it's per usage. It's per time. How many IOPS is free? Good question. I don't know the number. Actually,
Incoming traffic is free, outgoing traffic.
yeah, charge. Yes, for I think it's 5K IOPS are free, incoming and outgoing. So you don't pay.
Pricing chart.
Yeah, there's a pricing chart is there, but it's because you have to know exactly what you want to what the application profile is.
For example, Amazon using RDS would charge me the reading amount to charge per hour plus the charge me the reading and writing.
Yes.
Only if you choose yes.
RDS.
For example, in Google Compute Engine, okay, for 50 gigs of storage and 10 gigabytes of access, you pay $2.50.
I know, but I suppose
Total.
in the question, do you have additional charges? For instance, in Amazon, depends on what you choose. You pay, for instance, to buy the EC2 instance, you pay per hour, but you additionally pay for this usage if you choose the EBS as storage.
As storage, no. I'll show you the pricing chart that they have. Okay, because it depends also on the type of machine you spin up. So first, we have to decide which service are we talking about. If we're talking about the compute engine, okay, there's a charge per configured machine. So if you have the big one, the per hour rate is higher. Okay, and then if you have a persistent block storage disk, if it's SSD, the cost is more versus the standard disk. Okay. So here is the pricing for compute engine. Okay. So the one we spooled up, it was this one, and one standard. Sorry, the one we spooled up was the micro one, which is I think this one. So I'm being charged a 1/12 of a penny per hour, and 13th of a penny if it's in Europe. This is the charge. But the thing is, if you keep using it, it'll become cheaper for you. So they want you to keep it up for a long time. So they're saying, once you use an instance for over 25% of a billing cycle, your price starts dropping. So hopefully that answers your question.
So you only charge about how much you are running this system.
Yes. So there is the network pricing. See, egress into the same zone is free. Okay. And then, depending on where the traffic is coming from, if you have load balancing protocol formers, here is the persistent disk pricing. So that's what I said. It's different if you have SSD, if you have SAP storage. IOPS are free. So it doesn't matter. So because the penalty, you're
It's the same with the last thing that you assigned but unused through bank.
okay. Any other questions? Yes.
Our regular computer and the computer engine, we can do the same. There is not.
Yes, it's exactly the same. It's exactly the same. Yes. There's no difference. No difference. There's nothing you can do on your computer, assuming that it's the same operating system. Like if you're on a Mac and that's on a Linux, okay, you have to compare apples and apples. But the Debian machine I spooled up, it's exactly like any normal Debian computer that you have. There's nothing you cannot do on it. There's no restrictions. Questions? Further questions? No? There was an inquiry about cloud endpoints. So I'm just going to go ahead and do a quick rundown on Google Cloud endpoints. Okay. And what's your specific question?
What's the difference between endpoints and you write your own backend?
The work you're doing. The work that you do. That's it.
Yes.
That's it. So suppose you have an App Engine application, okay? And this application is storing some data somewhere. And you want to now have an API for this data. This is where Google Cloud Endpoints comes. So you don't write your API code as part of your App Engine code. Does that make sense? So your App Engine just does the CRUD part. So it has the forms where people can fill in. It stores data into your data store. Everything is normal. Now, you want to create an API on top of this because you want to use this data in your mobile application. Here is where you'll bring in the Google Cloud Endpoints. And they're available only for Java and Python.
Is it just interfacing to your database, or can it interface with its
As far as I know, it interfaces with data store, cloud storage, mail, and one more.
So it can deal with binding?
Yes. Questions?
I have a couple of questions about how they are. Google Cloud Compute can calculate by tenants.
Yeah.
With a minimum of tenants. Whereas the next competitor will only
Charge by the hour. It's like mobile phones. They used to charge you by the whole minute, not the second.
you're using a very expensive.
But the 106 GB one? Wow.
The fact that you only pay for attendance is
Okay. The other thing that I would recommend that Google's services over, let's say, Amazon or Heroku is a lot of the services that your application needs are available directly from Google. So if you want to send mail, they have Gmail plugged into it automatically. If you want to have single sign-on, they have Google sign-on implemented automatically for you. So you don't have to go here and there to fetch. If you need a ephemeral storage, if you need a cache is available for you directly from Google. Like if you go to Heroku, if you need email, you have to decide which one of the 7, 9 email providers that you like and plug them in and then modify your application. In Google App Engine, it's one standard API that covers all services. So it's a lot more convenient from a developer's perspective. There was a question. Yes?
Yeah, I have a question about it. In Amazon, you have simple mail service.
Yes. Yeah.
Uh,
There's something similar here.
Okay, I wanted to add it works better when it comes to debugging. I didn't check it here.
It doesn't
But as
work.
you know, in simple mail service, you know what the amount of the mail sent, you know what the limit. But
Yeah.
for instance, you don't know if some mail haven't been sent and you get it back.
Okay. Simple email service is basically SMTP box, right? The mail service here is a complete API. You never see the box. You don't set up anything. You got it? You just send mail from your application, and they deliver it for you using their delivery infrastructure. So SES is one level below this. If you wanted to develop a company that allows others to send email using an API, you would go sign up for Amazon SES, and then you would develop your application on top of that, and then you would write your API on top of that. But in Google App Engine, all that is taken care of for you, so you just get the API directly from you. Yes. And the good thing is, if you have users signed in your app, you can send email on their behalf in Google App Engine, which is a lot more easier to do.
That,
Yes. Yes. Questions?
So can start
You can. They will restrict you, obviously. Um, if you want, I can give you the exact.
what is it?
For analytics, they've tied up with SendGrid, so they can do bulk mail analytics for you. Sending bulk mail, yes. They will give you bounce notifications in your API as well. If you want to know the quotas and limits for sending mail, 10 megabyte maximum size of the message, and 16 kilobytes if the recipient is an administrator. That's it.
I was interested in one of the things, and see the problem with the cloud. When you have services in the cloud, many companies that have services in the cloud say, our client haven't received the mail. And now it's very hard to find the problem. What happened to your emails? The reason I'm asking how you can hear, because it's like,
Okay, I got it.
I don't know.
No, in Amazon's case, what they do is before they allow you to send emails publicly, you have to go through a qualifying period, right, with SES, and then the responsibility of making sure your IP is clean is up to you. Here, you don't worry about any of that. So it's a higher level abstraction. It's like you're using MailChimp or something like that. Yes. Questions from the peanut gallery? No? Understood everything? Okay. What did I talk about? It's going to go away now. What did I talk about today? Give me a summary. Okay. That was one. There were like 6 blue blobs. So there was compute engine, app engine. What's the difference?